In this lecture, we are going to basically concentrate on the two types of problems, that is the stress as well as strain. I just go for the problem, a steel rod 2 meter long. Whenever we say the steel rod 2 meter long, that means they have given the length of a rod, that is L is equal to 2 meter and 24 mm diameter. The diameter is 24 mm, so it is just I am writing the given data. Is subjected to axial pull of 40 kilonewton. So you can say it is a 40 into 10 raised to 3 Newton. If the elongation of the rod is 0.5 mm, if the elongation is 0.5 mm, that means delta L is given as 0.5 mm. Find the stress induced and Young's modulus of elasticity. So the first thing I will find here, I know that what is stress? Stress is force or pull applied per unit area. Now what is the force? That is 40 kilonewton, that is nothing but 40 into 10 raised to 3 Newton upon area. Whenever I want to find out the area, I should have to know that as the rod is a circular, because its diameter as given, it should be pi by 4 d square. I think it comes around 452.38 mm square. So I will put this value here, that is 452.38. If I put this value here, I will get the answer near about 88.41 Newton per mm square, or you can say it is a MPa. This is the first thing. What they have asked in the second point, they say calculate the Young's modulus of elasticity. We know that E is equal to PL upon AE. PL upon A, sorry, we just write in a different way. Instead of that, I write here delta L. Delta L is equal to PL upon AE. So E is equal to, what will happen? It will be PL upon A into delta L. Now the next second thing, either convert the L into mm or delta L into the meter. So instead of that, I will convert everything into mm. So it is a 40 into 10 raised to 3 into length is 2 meter. I will convert that into the mm, that is 2000 upon area is known to us, we have already calculated, into delta L, that is 0.5. So I think the answer is around 353.67 into 10 raised to 3 Newton per mm square. Calculate minimum diameter of steel wire to lift a load of 8.2 kilonewton. So first thing in this case, what they say, calculate the minimum diameter of a wire. So it is a wire whose diameter should have to be calculated, but what they say, that wire should have a load of 8.2 kilonewton. I write it 8.2 kilonewton, but I know that I should have to convert it into Newton. So it is a 8.2 into 10 raised to 3. This will be a Newton. Second thing, if the permissible stress, what is the permissible stress? Permissible means maximum stress that material can sustain. So permissible stress is 120 MPa. But we know that MPa is nothing but Newton per mm square. So I will write it as 120 Newton per mm square. Now I know the formula for stress, that is sigma is equal to, or stress is equal to force per unit area. So here sigma is equal to P upon area, but it is a circular rod, so it is a pi by 4 d square. So I can say sigma is equal to 4 comes in numerator, 4p upon pi d square. So I will just say d square is equal to 4p upon pi into sigma. That means d is equal to root of this. I just put here the values. What is p? P is 8.2 into 10 raised to 3. Pi will be as it is, and what is sigma? That is 120 Newton per mm square. I will just find the answer and tell me what it comes out to be. It comes out to be 9.33 mm. An aluminium bar 1.8 meter long has a 25 mm square cross section over 0.6 meters. So for first half is different of its length 20 and 25 mm cross sectional area over 1.2 meter length. How much will be the bar elongate under a tensile load of 17500 Newton? So I will make the two different sections. तुम्ही जर याचा विचार केला तर मी याला दोन पार्ट मध्ये डिवाइड करतो. एक हा पहिला पार्ट आणि हा दुसरा पार्ट. याच्यात जे इलॉंगेशन होणार आहे त्याला मी म्हणतो डेल्टा L1, याच्यात होणार आहे त्याला मी म्हणतो डेल्टा L2. बट what will happen then? Delta L is equal to total bar चं elongation म्हणजे किती? Delta L1 plus delta L2. But we know काय माहिती आपल्याला मित्रांनो? We know that it is a PL upon AE. So I say it is a PL upon AE for first, same thing PL upon AE for the second section. But the thing is load दोन्ही वरती सेम आहे कारण टेन्साईल लोड एकाच ठिकाणी दिसतोय म्हणजे तो आतल्या पण रॉडला कंटिन्यू आहे. So P is same. E is same because the material is same. म्हणजे बदलणार काय? L आणि A. So whenever you are applying this, delta L is equal to P किती आहे बाबांनो? चेक करा. 17,500, 17,500 into L. लेंथ किती आहे पहिली? 0.6 मीटर म्हणजे किती mm? 600 डिवायडेड बाय एरिया, पण तो स्क्वेअर सेक्शन आहे म्हणजे 25 चा स्क्वेअर इंटू ई किती आहे? 75,000 प्लस PL अपॉन ए. पण परत एकदा लोड किती आहे? तेवढाच आहे पण लेंथ बदलली आहे. किती आहे? 1.2 मीटर म्हणजे 1200 mm. एरिया किती आहे? पाय बाय 4 d स्क्वेअर, पाय बाय 4 d स्क्वेअर और पाय आर स्क्वेअर. डायमीटर माहिती आहे मला. किती आहे डायमीटर? 25 mm in cross section. So it is a 25 bracket square. So pi by 4, 25 square, and E is again 75,000. फक्त कॅल्सी तू व्हॅल्यू टाका आणि उत्तर काढा. आय थिंक द आन्सर इज अबाउट 0.794 mm. So now here we come to the shear stress. Now what is the shear stress? Shear stress is nothing but shear force per unit area. Let us take an example. Suppose we are having two plates. Suppose this is the first one and this is the second one. If these are the two plates and they are joined together by, they have been joined together by using some rivet, suppose, or suppose I am saying here some one of the nut has been applied or passed through it, and if the force is applied perpendicular to it, if the force is applied perpendicular to it, what will happen? Suppose that nut fails. How it fails? The two plates will get separated. If the two plates will get separated, just observe, this was my nut, and if I am saying this is the upper plate which is applying a force in this direction, and this is the lower plate in which the force is applied in this direction, then this will fail on this area. Where it is the failure occurs, that failure is seen on its area, that is nothing but pi by 4 d square. Suppose instead of two plates, if there is a one more plate at the top, and if this rod has been passed to it, then this may fail at two positions or two areas. So in that case, I may say it is 2 pi by 4 d square. So what is the parameter, dear friends? The first thing in this case, the failure occurs if there are the two plates, the failure occurs on a single surface, whereas if there are three plates, the failure occurs at two stages or the two surfaces, that is 2 pi by 4 d square. So you should have to know the first one is a single shear, whereas the second one is a double shear. Let us take an example of shear strain. Suppose there is a one book which is kept on a table, and if a force is applied on that book on the top surface, if the force is applied on that book on a top surface, what will happen? Just here, whenever the force is applied, its position will change. That means this book will take a new position. Let I say that gets deformed like this. If that book gets deformed like this, what it indicates, there is a deformation occurs this much on the height of this. So it is the ratio of distance deform to the height. Let I say that this distance deform is x and the length, that is L. So what it is the x by L. So shear strain is defined as the ratio of distance deform to the height. So just keep in mind the formulas for the single shear, double shear and the punching shear, which is the one more. We have already seen the single shear is nothing but P by A, as the two plates whenever joined, only the one area where the nut is failing or it just break at the one position, that is pi by 4 d square. Same thing if the three plates have been joined, it is at 2 points. And if instead of that, let me discuss one more parameter, dear friends. Suppose the one paper is there and if I want to punch it, what will happen? How much area is affected by the punch? Only the circumference. But if instead of this, suppose I want to punch a surface or a plate which is having a more thickness, where the problem is it could not be easily punched. Why? The thickness is more. So where is the surface area for the punching? This one is the surface area for punching. So how much it is? It is a pi d is the circumference and the thickness is t. So what it is? It is pi dt. So the punching shear is pi dt. Again the same thing. In case of punching shear, this is the area. So whenever I am finding out the punching shear stress, that is nothing but P upon A. But here the area is nothing but pi d, that is the circumference into the thickness of plate. Let us take one problem on stress and strain combinedly. For the linear stress and strain, here an aluminum bar 1.8 meter long has a 25 mm square cross section over 0.6 meter of its length and 25 mm circular cross section over 1.2 meter. How much will be the bar elongate under a tensile load of 17,500 if Young's modulus is 75 MPa? Here I divide this section into the two parts. Let I say the first one is this and this is the second one, and the elongation will be denoted by delta L1 and delta L2. So what is the total elongation we expect? We expect total elongation delta L is equal to delta L1 plus delta L2. But what the thing is, I know that delta L is nothing but PL upon AE. So I will say it is a P1 L1 upon A1 E1 plus P2 L2 upon A2 E2. But the thing is, load applied is same on both the rods, but lengths are different. Again, the Young's modulus is same because the material is same. So whenever we apply it, what it is a 17,500 into the length, that is 0.6 meter. I will convert it into the mm, 600 mm upon area, as it is a square. So it is a 25 square is the area and 75,000 is the Young's modulus, that is E, plus same load is applied on the second section also 17,500, but length of that section is 1200 mm upon area of cross section, that is pi by 4 d square. What is d? 25. So it is a 25 square into 75,000, and then you should have to solve it and you will get the answer after calculating it. I think it comes around 0.794 mm. Let us consider one problem on shear stress. Calculate the force required to punch a hole of 330 mm diameter, 30 mm diameter in a metal plate of 20 mm thickness. So what they have given here, D is given, Whenever the D is given, what is D? D is given as 30 mm. So I say D is equal to 30 mm. And the thickness of the plate is provided, that is 20 mm. Now I know that shear stress is equal to 4 per unit area. But what type of this is? Calculate the force required to punch. Whenever I say punch, that means it is a P upon pi dt. So what is P? They say it is a 400 Newton per mm square. That is a permissible shear stress in this case. And force required should have to be calculated. So what I will say, P upon pi dt is equal to 400 Newton per mm square. So what I will get, whenever I find the answer, definitely I will get the P in Newton, but along with that I should have to enter all the values. So what the P will be equal to? P will be equal to 400 Newton per mm square, that is MPa, into pi into D, that is nothing but 30, into T, that is nothing but 20. So I just have to multiply it and write the answer. I will get here the answer as 754,285.71 newtons, or you can say it is a 754.285 kilonewton.